Hi everyone, today we're talking about lesson 7.5, dilations. And I think these are super fun. It kind of seems like a standalone lesson that's a little bit different. It's getting a little bit into geometry, but a dilation makes something larger or something smaller depending on a scale factor. The scale factor, another name for scale factor, is the multiplier. It is, if you look at it as a multiplier, then you won't get lost in these problems. So I'm going to write that on here. Look at it as your multiplier. It's something that's going to help you multiply the points so that you can dilate your shape. It's going to be bigger in all areas of your shape, proportionally, of course. So let's get started on the first one. It says a triangle has vertices of -4, 2, 0, 2, and -4, -2. And it says it was enlarged, and enlarged means bigger. So we want our picture ultimately to get bigger, with the origin as the center of dilation. And all that means is that the origin is almost like your point of perspective. All of the lines of dilation will line up there. All of the vertices will line up. And that's the point where it almost like starts, if you will. All the lines would gather there. It says graph the original image and the dilated image. So first I'm going to graph the original image. -4, 2. And you're going to label absolutely everything. So this is A. Point B is 0, 2 here. And C is at -4, -2. Okay, I'm going to draw my triangle. Okay, so I have my triangle nice and drawn and all my points. That is my original image. Now it says we want to dilate it by a scale factor of 1.5, which means that's the multiplier. Now you can show me work in a number of different ways, and Mrs. Von Block may ask you to do something different. You can just do times 1.5 here if you'd like, or she may have you do, and I may have you do, I may change my mind, -4, 2, B is 0, 2, and C is -4, -2. And you're going to do times 1.5 times 1.5 times 1.5. And that is to each of the coordinates. So if I do -4 times 1.5, and you're of course allowed to use your calculator. And I would even check your answer. If you think you're confident and you guys are so smart and you are confident, but just, you may want to check just in case, like, you know what, I might do 1.5 times 2 just to make sure it's 3, just to make sure you get the right things. Now 0 times something you should be able to handle, which is 0. 2 times 1.5 is 3. -4 times 1.5 is -6. And then -2 times 1.5 would be -3. I'm going to use a new color for our new drawing. I'm going to graph it as well. -6, 3. Would be here, A. New A. That little hash mark just means it's the new A. 0, 3 is the new B. New B. And the new C is at -6, -3. 1, 2, 3. And then I'm going to color it in darker when you kind of make a mistake. All right, let's go back. Make my new drawing. It should be bigger than the last. And those points of the center of dilation that I was talking about is if I were to line up, I'm going to use a black line here. If I were to line up all the old vertices with the new vertices, they would converge at the origin, which all of these do. So that means we did that correctly. I'm going to erase those so they don't scare you. Did we do everything we were supposed to? Did we graph the original image? Check. We graphed the dilated image? Check. We showed all of our points? Check. And we labeled everything. Awesome. So we're going to get full credit. Let's go on to the next one. Example 2, same idea, except now we're doing a rectangle. We were asked to reduce, which means our picture is going to get smaller. So our rectangle should be getting smaller by a multiplier or a scale factor of 1/2, with the origin as the center of dilation. Graph the original and the dilated. So the original one is 6, 2. Original A, original B is negative 6, 2. Original C is 6, negative 4. And original D is negative 6, negative 4. And we're multiplying each of those by a half, which, when you multiply by a half, it's the same as dividing by 2. It should make everything, like cut it in half. If you had a $10 bill, it'd be $5. If you had a $5, it'd be down to $2.50. So we're going to cut each of those in half. And 6 times a half, 3. 2 times a half is 1. Negative 6 would be negative 3. And 2 times a half is 1 again. 6 times a half. Luckily, there's a lot of like repeats. So it's like if you get it right, then you're cruising. If you get it wrong, however, you better go back and check because you're going to get quite a few of these wrong then. Negative 3, negative 2. Let's graph them. So the original was at 6, 2, A. Don't forget to label. Negative 6, oh my gosh, this is a huge rectangle. Negative 6, 2 is B. C is at 6, negative 4. D is at negative 6, negative 4. Put everything, oops. I think I'm pressing too hard. Put everything together. Big rectangle. Now we're going to graph the one that should be cut in half. Now remember, it's proportionally cut in half. So it truly isn't going to be half in size. All of the proportions of it are going to be half. So it's going to be at 3, 1. That's the new A. New A. Negative 3, 1. New B. 3, negative 2. That's the new C. And negative 3, negative 2. New D. Now I always tell my class when we're live in person, if your picture looks like all of a sudden a triangle or a bunny rabbit or a flower, you did something wrong, okay? If you started with a rectangle, you should end with a rectangle. If you started with a triangle, you should end with a triangle. The shape should look exactly like the original, but just smaller, or exactly like the original, but just bigger. Keep that in mind as you dilate. Bye.